Myself, Dr. Naresh Kumar, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, I discuss first order and first degree differential equations. Previous, we have discussed several methods like as variable separable, change of variable, homogeneous differential equation, and also discussed a method which is very important, linear differential equation. And we have solved some problem on this differential equation. So now today I want to solve some more problem depend on method 4, linear differential equation. So now this problem given here depend on based method 4, linear differential equation. So problem 1 is solve dy dx, this is dy dx plus sec x into y is equal to 10x, this is equation 1. So how we can solve this? This is linear differential equation of first order and first degree. So the general linear differential equation is this: dy dx plus py is equal to q. We have discussed widely in the method of linear differential equation, and we find out the integrating factor and the solution of linear differential equation. So now this equation is 2 and this equation 1. Here we compare with 1 and 2. Now comparing equation 1 with this general linear differential equation, then we get P. P is here sec x. P is sec x and Q is 10x. This Q is 10x. We find. First of all, any question is given in the question paper of linear differential equation. Then we find out the value of only P and Q. Nothing is known, only P and Q are known in the question. So now, first I am taking integrating factor. Integrating factor. That factor is very important factor. Why this factor we multiply to the question in each term on both sides, then differential equation is integrable. So this factor is e to the power integral p dx. So this equal to e to the power integral. P is sec x and dx. So this equal to e to the power integration of sec x. Sec x means log sec x plus 10x. Integration of sec x is log sec x plus 10x. And so the e to the power log. E to the power log means this is e inverse to log. So this cancel to this, we get sec x plus 10x. This is an IF. Now, here note that integrating factor of linear differential equation is IF. IF integrating factor e to the power integral p dx. This implied that e to the power integral p is sec x dx. Now e to the power log sec x plus 10x. So e cancel by log, this is inverse to each other. So we get sec x plus 10x. This is an IF. Now solution formula. This is solution formula of a linear differential equation. So here we find out this IF. So final answer is y into IF. IF means sec x plus 10x equal to integration q. Q is in our question, q is 10x here. So q is 10x, putting value of q 10x, and into IF putting sec x plus 10x and dx. Now integrating right hand side, this side integrating. So this y into sec x plus 10x equal to integrating this. So multiply by tan x, sec x tan x and dx plus tan square x and dx. Now sec x tan x, integration of sec x tan x is sec x tan x and plus integration of tan square x. Tan square x means sec square x minus 1 dx. Sec square x minus 1 sec x tan x. Integration of sec x tan x is sec x and this is sec x and plus integration of sec square x dx and minus dx. So this integration of sec x and plus sec square integration of sec square x is tan x. Sec x plus tan x and plus minus x plus c. This equal to y into sec x plus tan x equal to this. So this is the solution of this question. Okay, this integration of tan x and minus x plus c. This equal to y into sec x plus tan x. So this is the complete solution of this question. Next problem, problem 2 based on again method 4 linear differential equation. This is linear differential equation. Linear differential equation. So this problem 1 minus x square dy over dx plus 2x into y equal to x into 1 minus x square 1 by 2 this one. So comparing this equation, writing this equation 1 in general form. General form is this: dy dx plus py is equal to q. In any question of linear differential equation must be in the type of this. First is dy dx, first derivative. There is nothing before dy dx. Here is multiply 1 and plus py equal to q. But in our question, dy dx, before dy dx is 1 minus x square. So 1 minus x square is removing here. Then dividing by 1 minus x square on both sides. Dividing by 1 minus x square in question, in given question on both sides. On both sides. Then we get dy dx, here dy dx plus 2x into y upon 1 minus x square and equal to x into 1 minus dy dx plus 2x into y upon 1 minus x square equal to x into 1 minus x square to the power half upon 1 minus x square. So this power is 1, this power is half. So in denominator we get half power. Now dy dx plus 2x into y upon 1 minus x square equal to x into 1 minus x square to the power half. This equation, this 2 and this 3 equation. Now dy dx plus 2x into y upon 1 minus x square and equal to x into 1 minus x square to the power half. This equation 3 and dy dx plus py is equal to q. Comparing these two equations, comparing on both sides, we get p is equal to 2x upon 1 minus x square and q is equal to x upon 1 minus x square ka root. Now we find out an IF, integrating factor IF. Integrating factor IF e की power integral p dx. So e की power integral p dx 2x upon 1 minus x square dx. So this is the differential of this function here dx. dx. So this is the total differential of this. So we can write this e to the power minus log 1 minus x square. 1 minus x square का differential 1 upon 1 minus x square. Minus x square means minus 2x dx, this one. So here we can write e to the power log 1 upon 1 minus x square. So IF is 1 upon 1 minus x square. This is IF, integrating factor. Now solution formula, y into IF is equal to integration q into IF and dx plus c. This is formula for solution of a linear differential equation. Putting value here, y into IF 1 upon 1 minus x square equal to q. What is q? Q is x upon under root 1 minus x square and into 1 upon 1 minus x square. This is IF and dx plus c. So now here y into 1 upon 1 minus x square equal to integration x into 1 minus x square to the power 3/2 and dx plus c. So integrating this term here, multiply 2 and divide by 2. So now let 1 minus x square equal to t. So 0 minus 2x and dx is equal to dt and minus 2x dx is equal to minus dt. This value putting here. So this y into 1 upon 1 minus x square is equal to 1 upon 2 integration 2x dx. 2x dx. 2x dx means minus dt. 2x dx means this result and this result. Putting here, this equation is 4 and this 5 and this 6. 5 and 6 putting in 4. From 5 and 6 putting in 4. Then we get here minus dt upon here t. This result is t to the power 3/2 and plus c. So what is integration of this? Y into 1 upon 1 minus x square equal to half and minus 1. This t to the power minus 3/2 and dt plus c. So here plus adding here minus 1/2 and t to the power minus half upon minus half. So minus half is cancelled plus c. So final answer is this y upon 1 minus x square equal to here is 1 upon root t. Minus half minus cancel 1 upon root t and plus c. So 1 upon root t means so y into 1 minus x square equal to 1 upon root t means 1 upon under root 1 minus x square plus c. Now multiplying by this, so y equal to here root 1 minus x square and plus c into 1 minus x square. This is complete solution of the here is under, here is 1 power. Next problem, base 3. Problem 3 based on method 4, linear differential equation. This is linear differential equation. And here question is if dy dx plus 2 tan x into y equal to sin x. Initial conditions are given here. Initial conditions are given in this question. Okay, so this question is very important. If initial condition are given in question, then these initial condition putting in our solution and we get the value of the constant Again putting the value of the constant, then we get solution. That is known as a singular solution. So now, first of all, I am solving this. So dy dx plus 2 into 10x into y is equal to sin x. This is the question 1. I am writing general equation dy dx plus py is equal to q. This is 2, general equation. Comparing with 1 and 2. Then p equal to 10x and q is equal to sin x. Now we get if, integrating factor. This is e to the power integral p dx. E to the power integral p is 2 10x. 2 10x dx. Integration of 10x, sin upon cos 10x. e to the power 2 10x का log sec x, integral is log sec x. Sec x का 1 upon sec x differential or sec x 10x. Sec x cancel this. So this e to the power sec log, this is square taking to here, sec square x. So now if is e to the power log sec square x. So if is sec square x only. This is integrating factor. Now this factor solution procedure, solution formula. Formula for solution. Formula for solution of linear differential equation. So this formula is y into if equal to integration q into if whole dx plus c. So y into if is sec square x equal to integration q is sin x. So q is sin x here, sin x, and if is sec square x and dx plus c. Now this term integrating this sin. So here sin x and sec x into sec x dx. Now sin x, sec x is 1 upon cos x into sin x, and this is integration this 10x and sec x dx. Sec x 10x, sec x का differential sec x 10x. So the integral of this result is sec x and plus c. So y into sec square x. So this is equal to by sec square x. Dividing by sec square x here. Divide sec square x equal to sec x plus c. So now dividing by sec square x to this side. So y equal to sec square x, 1 upon sec x. Sec x upon sec square x and plus c sec square x. C upon sec square x. So this 1 sec x cancel means cos x plus c cos square x. This is complete solution. Now apply initially condition. Apply initially condition. Given in the question. Conditions are this: y equal to 0 for x equal to pi by 3. Y equal to 0 for x equal to pi by 3. So putting x equal to pi by 3 and by 0, y 0 equal to c equal to cos pi by 3. Here cos pi by 3, cos pi by 3 plus c C cos square pi by 3. Pi by 3. Cos 30. Cos 30 means sin 30. Sin 30 cos 30. Sin 30 half and cos 30 sin 60 root 3 by 2. Okay. Cos 60 1 by 2 and cos 60 1 by 2. Cos 30 root 3 by 2. Okay. Cos 30 root 3 by 2 and cos 60 half and sin 30 half. Sin 30 half. So these are basic values of sin and cos. Sin 60 root 3 by 2 same equal to cos 30. Cos 30 and sin 60 both are same. We can find this result 90 minus 60. So here writing this cos 30 means root 3 by 2 and plus c here is cos square root 3 by 2 ka whole square. So this equal to root 3 by 2 and plus c and here 3 by 4. So this 0. So this taking this side. So now value of c equal to minus root 3 by 2 upon 3 by 4 upon 3 by 4. So here 4 this c equal to minus 4 by this into this and this into this. 4 minus 4 root 3 upon 3 to the 6. So this result 2 3 is 6, 2 2 and this root 3. So this c equal to minus 2 upon root 3. This is the value of c. This putting in this solution, then we get complete solution of this equation. Here y is equal to cos x plus c. What is c? C is 2 by root 3 and cos square x. This is the answer. Now, next method 5. We want to discuss method 5 Bernoulli equation. This is the very important equation which is given by a great mathematician, also physician. This is Bernoulli. Bernoulli. The name of the mathematician is Bernoulli. He is given an important equation that is known as a Bernoulli equation. This equation is also known as a non-linear differential equation. Means this equation is non-linear. But this is reducible to linear differential equation. Means we can reduce Bernoulli equation in linear equation after applying some steps. Type general differential equation of Bernoulli equation is given as follows. This is type of this dy dx and plus py. This is the same part of linear. Left hand side is same part of linear. But right hand side is q. In linear is only q. But in non-linear or Bernoulli equation, here is some power of y to the power n. Some power of y to the power n. And n is any number positive. So here is some power of y to the. This is known as a Bernoulli equation or non-linear equation or reducible to linear equation. So how we can reduce this? d by dx plus py is equal to qy to the power n. This equation. We reduce this equation in linear. We reduce 1 in linear form. Okay. So dividing y to the power n on both sides. So we get 1 upon y to the power n dy dx plus py upon y to the power n equal to q. So here is plus p 1 upon y to the power n minus 1 equal to q, and this 1 upon y to the power n and dy dx. This equation is 2. Now let coefficient of p, taking coefficient of p is t. So let 1 upon y to the power n minus 1 equal to t. This equation 3. Differentiating with respect to x to 3. Then we get, so here y to the power minus n plus 1 equal to t. Minus n plus 1 y to the power minus n and dy over dx is equal to dt over dx. So now 1 upon y to the power n dy dx is equal to 1 upon minus n plus 1 dt over dx. So this result, this equation number 4. This result putting in 2. This 3. From 3 and 4 putting into putting into. So here this result is minus, putting here 1 upon minus n plus 1 and dt over dx plus pt is equal to q. Multiply this dt over dx plus p minus n plus 1 t equal to minus n plus 1 into q. So now this is linear differential equation. This is known as a linear differential equation, and can be solved by the method of linear differential equation. Okay, so this is the conversation of linear differential equation. Non-linear differential equation can be converted in linear differential equation, and that can be solved easily with the help of method of linear differential equation. So here some problem is given based on method 5, that is Bernoulli equation. Problem 1. This is very easy problem. We can solve here. Same problem. I am writing this is question 1. I am writing here general equation of non-linear equation of Bernoulli equation. So that is dy dx plus py is equal to q y to the power n. This equation 2. Similar power. Here n is 2. Here n is 2. So now same procedure apply here. Dividing by y square. In our question, dividing by y square on both sides in 1. So 1 upon y square dy over dx minus by 10x upon y square equal to minus sec x. This equation 3. 1y is cancelled. Now 1 upon y square dy dx minus 1 upon y 10x equal to minus sec x. So here let 1 upon y is t. Coefficient of 10x, this is p. Coefficient of p is 1 upon y. So 1 upon y is, let t, differentiating with respect to x. So here differentiate, this is minus 1 upon y square and dy over dx is equal to dt over dx. Now 1 upon y square dy over dx equal to minus dt over dx. So this equation is 4 and this is 5. This is 6 and this is 5. So now 5 and 6, from 5 and 6 putting in equation this 4, putting in equation 4, then we get, so what here? Here is minus dt over dn. This equal to putting minus dt over dn. And here this 10x into t minus 10x into t minus dt over dx and minus 10x into t equal to what? Right hand side? Right hand side is minus sec x. So here is minus sec x. Now multiply by minus sign. So dt over dx is plus 10x and into t equal to sec x. This is equation number 6. This is linear differential equation. This is linear differential equation. Linear differential equation. Now solving this differential equation by linear method. Linear method 4. So here again comparing this 6, comparing 6 with dy dx plus py is equal to q. Now p is 10x here and q is sec x here. If is e to the power integrating p dx. So e to the power integrating p means 10x dx. E to the power 10x log sec x. Log sec x means sec x is if. If is sec x. Now solution formula. Solution formula for linear differential equation. So y into if equal to q integration q into if dx plus c. This is basic formula. Apply in every linear differential equation for solving the solution, finding the solution. So y into if is sec x. Integration q, what is q? Q is sec x here. Q is sec x. Here q is sec x and if also sec x. So here is sec x and also sec x and dx plus c. So this is sec square x and dx plus c. So integration of sec square x is 10x. 10x plus c. So by sec x, dividing by sec x. So y equal to 10x upon sec x and plus c upon sec x. So y is equal to sin upon cos, sin x upon cos x into sec x and plus c cos x. So this one here sec x into cos x always 1. Okay, this is inverse to each other. So now y is equal to here sin x plus c cos x. So this is solution. Complete answer of this Bernoulli equation. Now problem 2 based on method 5 non-linear differential equation or Bernoulli equation. Bernoulli differential equation. So this question is also very important. Now here is general equation is dy dx plus py is equal to q by to the power n. Here is some function of y. With q, right hand side with q, there is some function of y. In our question, this equation 1, this equation 2. In equation 1, there is sec y. Sec y is function of y. We want to remove this from this step. So dividing by sec y on both sides. Dividing by sec y on both sides in 1. Then we get तो यहाँ आएगा sec y divide 1 upon sec y dy dx plus 10x into 10y upon sec y equal to only cos x. So here plus 10x and sin y upon cos y. Sin y upon cos y into sec y equal to cos x. And here is cos y dy over dx. Okay. So this cos y and sec y is cancelled to each other. So cos y dy over dx plus 10x and into sin y equal to cos x. In right hand side is q. Here is this is p. Coefficient of p is this sin y. So difference sin y, this equation number is 3. This is 3 equation. In 3 we consider sin y equal to t. Let sin y equal to t differentiating with respect to x. Sin y का differential cos y का differential dy dx, t का differential dt over dx. Okay. So this value and this value, here is this equation 3, here is this equation 4, and this equation is 5. 4 and 5 putting in 3 from equation 4 and 5 putting in 3. Then we get this 3 is this equation here cos y dy dx. So this value we have find here. This is the dt over dx. So dt over dx and plus. Now this is the 10x. 10x is p. 10x and this is t. Sin y is t equal to cos x. Equal to cos x in right hand side. Cos x. So this equation is 6. So this is linear differential equation. This is linear differential equation. Now comparing with dy dx plus py is equal to q. Py is equal to q. Py is equal to Q. So P is 10x, Q is cos x. Now IF. IF is e की power integral P means 10x dx. So integration 10x का sec x 10x. So e to the power log sec x 10x. Sec x log sec x 1 upon sec x 10x log sec x 10x का integration log sec x. Differentiation of this 10x 1 upon sec x 10x. So IF is sec x. This is integrating factor. Now applying formula for linear differential equation y into if integration q into if dx plus c. This is formula for linear differential equation. So here y into if is sec x equal to q. What is q here? q is cos x. q is cos x, if is sec x, and dx plus c. So cos x sec x is cancelled. Here is only dx plus c. So dx means x plus c. So y sec x. So dividing by sec x, y equal to x upon sec x and plus c upon sec x. So here solution is y is equal to x plus c into cos x. This is answer. Complete solution this. Bernoulli equation first to be changed in linear differential equation. Then we can solve this differential equation with the formula of linear differential equation. Now, one problem more we want to solve on non-linear differential equation or Bernoulli equation differential equation. This question also based on Bernoulli equation. So here this is P. P is 2x. 2x is P only. This is P. So let tan inverse y equal to T. Coefficient of P is T. This equation is 1 and this equation is 2. Differentiating with respect to x to 2 on both sides. On both sides. So now differentiation of tan inverse y with respect to x. Tan inverse y with respect to x, how we can differentiate this? So here 1 upon 1 plus y square and y dy over dx is equal to dt over dx. This is equation number 3. This is equation number 2. Okay. 2 and 3 putting in 1. From 2 and 3 putting in 1. Putting in 1. Then we get here. This total result is, this is dt over dx. dt over dx plus 2x and tan inverse y is t equal to x cube. This is equation 4. This is linear differential. Equation 4 is a linear differential equation. Linear differential equation. Okay. So linear this dt over dx plus 2xt equal to x cube. dt over dx plus 2xt equal to x cube. This is equation number 4. Now solving this, dy dx plus py is equal to q. This is general equation. So now p is equal to here 2x, q is equal to is x cube, if integrating factor is e की power integral p dx. So this e की power integral p 2x dx. So e to the power integral 2x square by 2, 2 cancel. E to the power x square. This is if. Now using formula y into if equal to integration q into if and dx plus c. This is formula. So y into if means e to the power x square equal to q is x cube into e to the power x square dx plus c. Now y into e to the power x square equal to integration q is x cube, e to the power x square dx plus c. So we are breaking this x square e to the power x square into x dx plus c. Now let here x square is equal to t. 2x dx is equal to dt. X dx is equal to dt by 2 y into e to the power x square. This equation is, this is 4, this 5 and this equation is 6. Now this 7 and this 8. 7 and 8 putting in this. So by e to the power x square is equal to integration. What is x square? X square is t. E to the power t and minus dt, minus not, and dt upon 2. Okay. So here integrating this 1 upon 2. 1 upon 2. We are applying here integration by parts. Integration by parts means t integration e की power t minus sine 1 e की power t. So this plus c. This by e की power x square. So now final answer is putting value of t here. Y into e की power x square equal to 1 upon 2. T is x square e to the power x square minus e to the power x square plus c. So dividing by x square, y equal to 1 upon 2 x square minus 1 plus c e to the power minus x square. This is complete solution. Okay. Non-linear differential equation. Now we start next new topic, new differential equation of first order and first degree, exact and non-exact differential equations. What are the exact and non-exact differential equation? So first of all, we define exact differential equation. Now a general differential equation, any type of equation, but writing this type, m is the function of xy, m is the function of xy, x and y, and n is also function of xy. This is f1, this is f2. There are m and n two element in our differential equation. M is the function of xy and n is the function to second function of xy. So a differential equation in the form m dx plus n dy. This is general form of a differential equation, which is exact or non-exact. We writing this type. Then coefficient of dx is m, coefficient of dy is n. M is the function of function 1 x y and n is also function of in x and y. So this differential equation is an exact. This differential equation is an exact if this verify the condition. Condition is del m over del y equal to del n over del x. We are using here partial derivative. Differentiation of m with respect to y partial. When we are differentiating with respect to y here, then x constant. And differentiating n with respect to x partially, then y as a constant. So this is the condition of this is the condition of an exact differential equation. Exact differential equation. Okay. Any differential equation in the form of m dx plus n dy equal to 0 verify this condition, then that is known as a exact differential equation. Otherwise, not non-exact differential equation. If not verify, then non-exact differential equation. So now we want to prove this differential equation, this condition. Here we want to proof of exact differential, proof of condition of exact differential equation, proof of condition of here, proof of condition of exact differential equation. M dx plus n dy equal to 0. This is given equation is an exact differential equation. Okay. Then it is the differentiation of some function, say f. Then we can write m dx plus n dy equal to df. Means any differential equation m dx plus n dy, if this is the exact means this is integrable, means this is some differential of function f df, and form f is the function of xy. So total differentiation of function xy is del f over del x dx and plus del f over del y dy. So this is the total differential of f. In f there are two variables. So this is known as a Euler formula. This is Euler formula. Euler's formula. Okay. Comparing here, we get m. M equal to here this m dx plus n dy. This equal to del f over del x dx plus del f over del y dy. Now this equation 4. Comparing this on both sides, then we get here m equal to del f over del x and n equal to del f over del y. Now integrating differentiating m with respect to y and differentiating n with respect to x. So here del m over del y equal to this function also differentiating with respect, so del 2f over del y del x. Now del n over differentiating with respect to n, differentiating n with respect to x. So del n over del x equal to again differentiating this del 2f over del x and del y. What according to partial differentiation partial differentiation del 2f over del x and del y, this equal to del 2f over del y del x. This is the property of partial differentiation. Property of partial differentiation. partial differentiation property. So with the help of this property, we can write here del m over del y equal to del n over del x. Okay, this is the condition of an exact. This is the condition. This is condition of an exact differential equation. Condition of an exact differential equation. This. So we are showing here here also del m over del y. This result and this result both are same. So del m over del y and del n over del x, these are equal. So this is required condition of of an exact differential equation. Exact differential. This is the condition of exact differential equation. Okay. Why the property of the partial differential equation? We know this result. This is equal to each other. Then from equation 5 and 6, we have found the condition this, and this is required condition of an exact differential equation. Okay. Solution formula for exact differential equation. We apply this formula for solving any exact differential equation and exact, then we apply this formula. What this formula? Integration m. M is given in the question, which is the coefficient of dx. Total m taken here. Integration m dx. Integration m with respect to dx. What here taking y as a constant. Plus now here taking n. Integrating n with respect to y. Only take term not containing x. We are writing in n. Only those terms we are taking here which are not containing x. Only y term we are taking. If x and y mix there, in any term x and y mix are there in our question in n, then we are not consider those terms. We are taking only those terms. There is only single element y. Single variable y is there in n, then we can consider here. Otherwise, not consider. If all terms in n are mixing with x and y, not separately y, then we taking n equal to 0 here. Okay. So this is the procedure here. Now, we solving based on exact differential equation. Here problem 1. I want to solve problem 1 based on exact differential equation. Test for exactness this. First of all, we check that this differential equation is an exact or not. So e to the power y plus 1 n into cos x dx. Next plus e to the power y sin x into dy equal to 0. This is equation 1. Now this m dx plus n dy equal to 0. This is general equation. General differential equation. This is question. This is question. This is general differential equation. Now comparing with 1 and 2. Comparing with 1 and 2. We get. Then we get m equal to here e to the power y plus 1 into cos x. And n equal to here e to the power y sin x. So differentiating m with respect to x, y. So del m over del y. Now here x as a constant. So cos x is constant. Here differentiating this e to the power y and plus 1 0. E to the power y and 1 0. plus 0. So this cos x. And now differentiating n with respect to x. So here del n over del x, this equal to e to the power y constant. Differentiation of sin x is cos x. So both are same here. This is e to the power y cos x. So here del m over del y equal to del n over del x. So this is the condition of an exact. So here condition here condition of an exact condition of an exact is verified is verified is verified. So given differential equation is an exact. Okay, here condition of an exact is verified, so given differential equation is an exact. Now solution passage here. Formula, we are using formula integration m dx y as a constant and plus integration n dy not contain x equal to c. So now here in m, this total term we are taking e to the power y plus 1 cos x integration e to the power y plus 1 cos x dx plus integration n here not contain x इसमें है, so we are taking here 0, here 0 into dy equal to c. So here in dy as a constant, this term is taking out e to the power y plus 1 and integration cos x dx and equal to c. So integration of cos x is sin x का minus cos x का sin x and e to the power y plus 1 and this equal to constant. This is the solution of differential equation. Integration of cos x is sin x. Integration of sin x is minus cos x. Now, thank you.
Like, share and subscribe. Hit the bell icon for more updates.